Welcome back. In this section, we're going to start introducing some vertical and horizontal shifts into our graphs. Before we start identifying the horizontal shifts, we may have to rewrite our trig function. As it stands, if you had something that looked like this, a sine of bx minus c plus d, you might be tempted to think about negative c here as somehow being the horizontal shift. And unfortunately, you would be wrong on that. If we're thinking about our function and wanting to identify the horizontal shift, we need to first rewrite it so that the b that's in front of the x has been factored out of both terms. So instead of sine of bx minus c, we factor the b out of both terms to get sine of b times x minus c over b. And it's this c over b that's going to be our horizontal shift, which we call a phase shift. So once we have our sine function or our cosine function, and it's been written in this nice form where the b that's in front of the x has been factored out, we can identify as before our amplitude and our period. Amplitude is absolute value of a, period is 2 pi divided by absolute of b. And then our phase shift and our vertical shift, phase shift being c over b, and our vertical shift being d. Amplitude and period, they both involve absolute values because both of those are measures of distance. Amplitude is the distance from the middle to the top or the middle to the bottom. The period is the distance from the beginning to the end of one cycle. Distances need to be positive, so amplitude and period, that's why they both involve absolute values. Phase shifts and vertical shifts could be positive or negative depending on whether we're shifting up or down or left or right. For a vertical shift, it's pretty much what you'd expect. If we'd had at the end of our function a little, for example, a plus 2, then our vertical shift would be 2. You'd be going up by 2, you'd be adding 2 to all of your y values. But when it comes to the phase shift, it's kind of the opposite of what you'd like to expect. If we're looking at something like cosine of x minus pi over 4, this is a shift to the right. And since we're shifting to the right, we're going to be adding pi over 4 onto all of our x coordinates. And it's for that reason I would say my phase shift is positive pi over 4. If, on the other hand, we were looking at sine of x plus pi over 3, that would have a shift to the left by pi over 3. You'd be subtracting pi over 3 from all your x values. That means your phase shift should be negative. So for that one, I'd say negative pi over 3. Okay, so let's start identifying some amplitudes, periods, and phase shifts. And of course, before I do that, I'm going to need to do a little bit of factoring. And that's from that middle part, that 3x plus pi, factoring the 3 out of both terms. 3x, when I factor out 3, leaves me with x. And minus pi, when I'm factoring out 3, that's what's left over. It's negative pi divided by 3. Remember, factoring is kind of like division, so if we wanted to think about what's left over when we factored 3 out, the answer is it would be whatever you had divided by 3. So in this case, x minus pi over 3. And so now we can identify our amplitude is absolute value of negative 5, which is 5. We can identify our period as being 2 pi divided by absolute of 3, which is 2 pi over 3. And since it looks like we've got x minus pi over 3, we're going to the right by pi over 3. So that means for my phase shift, I would say that it is positive pi over 3. So we've taken an equation and we've figured out its properties, and we might want to do the reverse. So we might have a cosine function in this case with a bunch of properties, and we want to figure out what's the equation of it. So the one thing that I can slot in right away, at least into that nice factored version, is the phase shift. I know that if we're talking about a cosine function, there'd be some number times cosine of some number times, in this case, since it's a phase shift to the left by pi over 2, then there should be a little x plus pi over 2 going on. So already I can slot in the phase shift part of my equation. I will need to do a little bit of thinking to figure out the a and the b for this equation, and I guess I'll do that here on the side. So if we're thinking about a and b, well, those come from amplitude and period. I know that the amplitude is 7, and the amplitude is the absolute value of a. So absolute value of a is 7. It turns out that we've got two possibilities then. Either a is 7 or a is negative 7. Similarly, you've got a period of 3 pi, and you know that period is 2 pi divided by absolute value of b. And so if we wanted to, we could solve for what b is by bringing the 3 pi down and bringing the absolute value of b up, and we get absolute value of b is 2/3. So again, there's also going to be two solutions for what is this letter. B is either going to be 2/3 or b is going to be negative 2/3. So if we're thinking about this, we actually had a second question which we can actually answer in advance now. Could we find a second equation with the same properties as the first one that we're going to find? The answer is yes, and in fact not just a second equation, but we could find a third one and even a fourth one, and that's because we have that a and b both could either be positive or negative. So if I wanted to say what are some possible equations that have all these properties, I could say, well, maybe you have positive 7 and positive 2/3. And that would be something that has the given phase shift period and amplitude. Or you could have used negative 7 and positive 2/3. Or you could have used positive 7 and negative 2/3. Or you could have used negative 7 and negative 2/3. All four of these equations, they all have exactly the same phase shift of negative pi over 2. Whether we're using b being positive 2/3 or negative 2/3, all of those would give you a period of 3 pi. So these four functions all have the same period. And whether we're using positive 7 or negative 7, the amplitude would still be 7, so all four of these equations all have the same amplitude. So our answer to the question, could we find a second equation? The answer is yes, and a third, and also a fourth. There's lots of different equations that all will have the same properties. Okay, now as far as the graphing side goes, it's not too hard for us to do because basically we're just going to do what we did before and one further step after that. So if you had yourself a transformed sine function like this, we know that when we're doing graphing by transformations, shifts have to come after the stretches. So we first basically ignore the shifts and just deal with the stretches. Figure out what are the 5 points for our stretched graph. Then once we've done that, we then move on to doing our horizontal transformations and vertical transformations, adding on the phase shift to all the x coordinates, adding on the vertical shift to all the y coordinates, and then there we go. We've now got our completely transformed 5 points. And then when we're graphing things, we can just do the same business as before. Draw one cycle, then use the fact that these functions are periodic to get as many other cycles as we need. That hasn't changed. Neither has the period. The period is still 2 pi divided by absolute value of b. That's the same as before. Also, the distance between our tick marks, that's the same as before. It's still the period divided by 4, or period times a quarter. So that means we've got a little bit of extra work to do, but not too much more, really. It's just one extra step. If we're graphing 2 cycles of this cosine function, the first thing I'll want to do is just rewrite this so that the 3 has been factored out. And so again, reminder when I'm doing this, if I'm trying to figure out what's left over, I'm going to think in terms of pi over 2 divided by 3, which is pi over 2 times a third, which is pi over 6. And there we go. So I already know in advance for later on that I've got a phase shift of positive pi over 6. And I've got a vertical shift of positive 2. So later on, I'll be adding pi over 6 to all of my x values. And later on, I'll be adding 2 to all of my y values. But that's later. Right now, I'm going to deal with the first part, which is just listing out what are all of the x and the y values for the basic shape y equals cosine of x. So we start again at the very beginning of things. Our x values are 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And our y values for cosine are starting at 1, going down to -1, then back up to 1. So there we go. We've got our basic 5 points for cosine, and now we're going to do the same thing, but this time get our basic 5 points for the stretched version of cosine. So we'll be looking at something where it's y equals -4 cosine of 3x. So ignoring the pi over 6 for now, ignoring the 2 for now, just dealing with our stretches, what are we going to get? So for the vertical side of things, we're going to be taking all of our y values and multiplying them all by -4. So taking all of my y values and multiplying them by -4, I get -4, 0, 4, and -4. And then as far as the x values go, I'm going to be taking all of my x coordinates and dividing them all by 3, which is the same thing as taking all of my x coordinates and multiplying them by 1/3. So 0 times 1/3, pi over 2 times 1/3 is pi over 6. Pi times 1/3 is pi over 3. 3 pi over 2 times 1/3 is 3 pi over 6, which is pi over 2. And then finally, 2 pi times 1/3 is 2 pi over 3. So I've got myself my nicely well labeled 5 points for my transformed sine function, or transformed cosine function rather. So now I want to do the last set of transformations, which is the transforming the x and the y values with our shifts. So now I'm going to be looking at doing my horizontal shift, my phase shift of pi over 6, and my vertical shift of 2. So for all of my y values, that'll be sort of the easier, nicer one. All of my y values, I'm going to add 2 to them. So taking all of my y values from my stretched graph and adding 2, I get -2, 2, 6, 2, and -2. And then for my my x values, I'm going to be taking all of my original x values and adding pi over 6. So 0 plus pi over 6 is pi over 6. Pi over 6 plus pi over 6 is pi over 3. Just as a little side note, if you're wondering how I'm doing that, if I'm adding pi over 6 plus pi over 6, I can think in my head about ignoring the pi for now and just what is 1/6 plus 1/6, or use my calculator. 1/6 plus 1/6 is 1/3. So that means pi over 6 plus a pi over 6 should be pi over 3. And that's sort of what I'm doing in the background for all of these. For all of these calculations, when I'm figuring out what's the new x coordinate, when I'm adding pi over 6. So for the next one, I would be asking myself, pi over 3 plus pi over 6, or in other words, what is 1/3 plus 1/6? Turns out to be 1/2, so pi over 2. Pi over 2 plus pi over 6 is 2 pi over 3. 2 pi over 3 plus pi over 6 is 5 pi over 6. One thing just to notice here is if you're sort of imagining what's gone on, we've kind of just taken all of our x values and shifted them over by 1. In other words, so instead of 0, pi over 6, pi over 3, and so on, we're sort of starting at pi over 6 and heading on to the right. So we're essentially using the same tick marks that we would have had on our graph if we were thinking of just the stretched graph. Just now we've shifted things over to the right by 1 tick mark. So if we'd been doing our stretched graph, it would have just started at 0 and gone all the way up to 2 pi over 3. Our stretched and shifted graph starts at 1 more tick mark over to the right, ending up at 5 pi over 6. So let's graph our 5 points that we had. So it was pi over 6 with -2, pi over 3, 2, pi over 2, 6, 2 pi over 3, 2, and then 5 pi over 6, -2. And I'll try to draw this as nicely as possible. And now for my second round, I'm just basically going to repeat this repeat this going backwards 1 cycle. So at 0, my y value will be 2, then it's 6, then it'll be 2, then back to -2 again. So we'll have our second cycle. And then only thing left to do is a lot of labeling. That is, again, one of the downsides to graphing a transformed cosine graph or a sine graph, and that is there's going to be a lot of points that will need to be labeled because many of them won't be at a tick mark. And in fact, almost all of these are not at a tick mark, so I've got quite a bit of labeling to do. And of course, we will also need to remember that in addition to labeling our points, I'll still have to remember to label my equations. So let's finish this part first, the labeling of the points. And then when we label the equation, you can label it either with the original or the factored version, either way. And there we go. So pi over 2 and 6. There we go. We've labeled all of our points. And I guess I'll label my graph right up here. It was -4 cosine of 3 times x minus pi over 6 plus 2. So I've chosen to label it with that sort of factored out, with a 3 factored out of it version. If you decided to label it with the original equation, 3x minus pi over 2 with the 3 not factored out, that's totally fine as well. So, and I would say there we go, we've got ourselves a nicely well labeled transformed cosine function.